Our goal is to delve a little bit deeper into probability studies, and that would focus on defining some basic terms in probability, namely experiments, sample spaces, trials, and events. To drive the process, I have an example here. Suppose you toss a coin twice and you're asked, what is the experiment here? Well, with experimentations, we tend not to know what the end outcome would be at the outset. So, in this case, when I toss the coin twice, before tossing the coin, either the first time or the second time, I don't know exactly what the outcome would be. Is it going to be a head or a tail? I do not know. So, based on that characterization of that process, we can say that the toss of a coin twice is the experiment here. Well, of the different outcomes of tossing this coin, there are many, many of them. I mean, quite about four of them. What can we list all of them out? So our next endeavor is to write out all possible outcomes of this experiment. Think of this dot as the coin the first time. It could lead to either a head outcome or a tail outcome. If on the first toss it leads to a head, on the second outcome it could be followed by either a head or a tail. Or on the first toss, if it led to a tail, on the second toss, that observation of a tail on the first toss could be followed by a head or a tail, leading us to four different outcomes. A head followed by a head on the first toss followed by a tail on the second toss, or a tail on the first toss followed by a head on the second toss, or a tail followed by a tail. These are the possible outcomes, and this is an exhaustive list of all possible outcomes associated with this experiment. That leads us naturally to what constitutes a trial in this scenario. A trial, you see, is a single performance of this experiment. So in this case, it would be a toss of the coin just once. Just once. So the two tosses constitute what? An experiment. So a single performance of a process whose outcome is not known in advance is a trial. Now, let's suppose that you're interested in outcomes that favor instances only where at most one tail occurs. Well, that would mean at most one tail means it could be the ceiling value is one. You can drop a little more. So, at most one tail will be, in this case, I have one tail. In this case, I have one tail. And also, in this case, I have less than one tail. So that also qualifies or fits the description of cases where you don't have more than one tail. In other words, we have zero tails there. So in this case, this is all of these outcomes constitutes what we call a subset of the sample space, where you have at most one tail. Why is this of interest to us? This would be later called an event. An event is always defined based on the different possible outcomes. It would usually be a subset of that what? Of the set of all possible outcomes. Let us give a name here. The name here for all possible outcomes, for the set of all possible outcomes, is the sample space of that experiment, otherwise written as capital S or denoted as capital S. So with this quick exercise, let us talk about the formal definitions of an experiment and other concepts here. You see, an experiment is a process that produces a single outcome whose result cannot be predetermined in advance of its performance, cannot be predetermined in advance. Whereas the collection of all possible outcomes associated with an experiment is called the sample space or possibility space of the experiment. Now, a trial is a single performance of an experiment, as we have illustrated earlier, whereas an event is a subset of the sample space or possibility space of an experiment. So with that, we note that whenever we have any process, like tossing a coin twice, whose particular outcome cannot be determined in advance, we have an experiment on our hands. And for every experiment, there is a set of all the possible outcomes that is otherwise called the sample space or the possibility space of that experiment. If we only carry out the process once, then what we have on our hands is a trial. And from every possible experiment with its sample space, we can define an event, which is a subset of all the possibilities that is of interest to us. If we invest in some kind of stock, the event of interest that we might be really interested in is making profits. That is an event of interest. Okay, let's see another example here on page 5. This example indicates that one automobile dealership sells Buick and Chevy automobiles. It also sells used cars. So you have Buick, Chevy, and used cars that it gets as trade-ins on new car purchases. If two cars are sold on Tuesday by the dealership, what do you think is the experiment here? Well, the experiment is that process whose particular outcome we do not know in advance. So when we sell these two cars on Tuesday, we don't know if it's going to be a Buick or Chevy or a used car. So the experiment here is the sale of two cars on that day of interest. Well, if we are to write out the sample space associated with this experiment, then I'll need to pick each of the cars on Tuesday. For the first car, it could be a Buick car. I'm using B to represent Buick, and Chevy, which is C, or it could be a used car. That is for the first car. After selling the first car, which could be a Buick, it could be followed by another Buick or a Chevy or a used car. Or the first car could be a Chevy car, followed by the second car, which is Buick and Chevy and used. Or finally, the first car could be a used car, then followed by a Buick, a Chevy, or another used car. So the sample space of this experiment would be the sample space denoted by S would be the collection of all possible outcomes. It could be Buick followed by Buick. So you have BB or BC or BU, or it could be CB. In this case, I'm on this track. CB, CC, or CU, or it could be UB, UC, or UU. This is the sample space associated with this business's undertaking on Tuesday. A little more on events, because we're going to be talking a lot about events. You see, as I said earlier, an event is a collection or a subset of outcomes from the probability experiment or from the sample space of the experiment. Usually, an event can consist of one or more outcomes of interest. So, for instance, in this example, if we define the event E, we usually define or denote events as capital letters such as E or any other capital letter of interest. If in this example we define the event E as the event that at least one of the cars sold next Tuesday is a used car. Take note, the emphasis on the word at least one is a used car. Which of these events or which of these points in the sample space is such that at least one of them is a used car? I'm going to highlight that. In this case, we have at least a used car here, at least a used car here, here, and here. So the highlighted points here would be the points in the sample space that satisfy the event E. In other words, if I were to have a listing of the points that satisfy, I will have BU, CU, UB, UC, and UU. Why is this of interest? This consideration is of interest because if we are told to compute the probability that at least one of the cars sold next Tuesday is a used car, then we are looking at the case where out of all possible outcomes, which we are going to quantify by numbering them. So I'm going to say the number of all possible outcomes. And how many was that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 9 possibilities or 9 sale possibilities, how many instances favor where you have at least one of the cars being sold being a used car? So I would say that will be number of points in favor of the event E, and that will be 5 of them. And here are those 5 points. So in other words, if I were to capture what is going on here, I would say that if the question overall here was find the probability that at least one of the cars sold next Tuesday is a used car, then I'll first need to consider the sample space, count how many possibilities there are, which is 9, then follow that up with how many points in this sample space favor that at least one of the cars sold next Tuesday would be a used car, in which case you have what? 5. So again, we go back to the beginning where we are using fractions to quantify the chances that an event would